Just delivered. It's an IN12C oven. Rather big. Obviously, that's a crate, but that's a little bit bigger than this little guy that I've been running all morning. So, I'm gonna pull this apart. I've got no way of getting it off. It's a metal pallet. The unit itself does have wheels, but it's gonna get off the pallet first. So, you know, it's only 400 kilograms or something. I'll just have my Wheaties or maybe go eat a couple of Mars bars and then I'll be able to lift it myself. I'll do my next video from the hospital. And here it is. It's my IN12. I've also got my restacker here. The restacker's on and the oven is on, but the production line is down at the moment. I'm not actually pick and placing right now. The oven is not heating, but I wanted to show you how it works and wanted to show you the restacker working. So it's a 6-zone oven, top and 6-zone bottom, so they call it 12 zones. You can heat the top and bottom individually, therefore the 12, and it's a conveyor-based oven, or what they call a chain oven, where it's got a chain conveyor, not a mesh, like my previous IN6. And you use the green buttons down below to adjust the width. And there are 4 thermocouple plugs down there to plug thermocouples in for profile tuning. And the oven itself has a pretty nice interface, touchscreen panel that folds down. I've still got the plastic over the top. So as you can see here, it's set up for my SAC 305, my water washable 1mm thickness PCB. And they're the temperatures that it would be set to if I had the unit on. And to turn it on, you just hit the power button. That's going to start it heating. The orange light there tells you it's not ready yet. I'll just turn that off. Tells you how much power it's drawing down the bottom. And it's a pretty nice interface. I've got fan control where I can set individually the rate of the fans per section. There's a file wizard for setting up solder paste. You can choose what type of paste it is and then a board thickness. I could say, well, it's going to be low temp and it's going to be whatever thickness, including metals, and it'll give you a starting point that you can then tune from. You can store up to 40 different profiles. As you can see, I've got a few profiles already stored in there. The curve setting screen is where you can plot the thermocouple graphs, 4 different colors for the 4 different ports, so you can tune your board over time. It's a product manual, which isn't really a manual, just a bit of information. And administrator panel, which, you know, shouldn't be changing anything on. It's pretty cool. Pretty basic, but that's all you need for an oven. Plenty of exhaust on the top. And the actual oven itself has the built-in HEPA filters at the start and the end, just like the IN6 did. So I don't really need exhaust. I've been running this the last few days, reflowing with it. And while it's running, I can't smell any fumes coming from the paste. It's doing a good job of capturing all of that. It does get quite hot, generates a lot of heat, obviously. It's an oven, but fumes so far is pretty good. Obviously, I need to replace the filters every few months and they're probably not very cheap. But by putting extraction fans on, going all the way to the ceiling, apart from the cost of doing that and having big tubes everywhere, it also wicks out the heat of the oven, potentially. So not needing that is a really good thing. I've actually put some boards in here that are going through the oven right now. They're just moving along the conveyor. Before I get to that, let's grab a panel, a tiny Pico panel, and stick it on the conveyor. As you can see, it'll just sit there and feed it in. Or maybe it won't. There we go. I didn't start it at the start, so it's turning this conveyor off too early. But it grips it and takes it. Obviously, the heavier the panel, the better it grips it. That's an empty panel right now. Doesn't have a lot of weight to it. And it's pretty slow going. The whole reflow cycle is running at 300 millimeters per minute for the entire length. Doesn't even hit the heat zone till about here, the start of the heat zone. And then at the end, there's a pretty long cooling area that starts about here that cools the board down on the way out. And then of course, I have it coming out of the oven there. You can see the cooling fans just inside there. The boards will come out and they restack into here, which I will show you when they come through. Not sure how far through they are yet. Oh, I can see them in there. starting to come close. So the oven also has a manual control for width at the back here and at the back down there, which you can use to either adjust the width of the conveyor if the controls aren't working, or to also fix the parallelism of the conveyor if there's a problem. It comes with a manual dial. Currently, the oven itself is only 240 volts, so it's just running off a single 15 amp connection. I haven't cut the cable yet and put a pendant connection on yet. I will. Shouldn't really be doing this in case it falls out, but I need to put pendant connectors on like these ones over there, but only plugged in a few days ago. So it's a pretty nice looking oven. It's considerably bigger than my Iron 6 was in terms of length. It's just over 2.5 meters long. It's quite bulky, but it holds its heat in pretty well. Like, I'm able to set the temperature zones to a lower level than what I needed to on the Iron 6 to get it to reflow. Well, you can see a board there. What I've done is just put 3 panels, one after the other, much closer together than what they would be if they were going through the pick and place machine, just to show you the stacking process, which is pretty cool. I was using it yesterday, so I was pick and placing and reflowing yesterday while I was upstairs working. Didn't have to worry about the boards coming out of the oven, didn't have to run down and grab them, and I could just hear it every so often. The restacker would pick up a board and stack it. It's pretty cool. So obviously this is only going to stack 1mm thick boards. If there were components on there, you'd see it stacking them higher, but here they come. Wow, nice. So it grabs it, pulls it all at the end and then lifts it. And it's sitting on some little pegs on the side, as you'll see when the next one comes through. So you can get stackers and destackers that use cartridges or magazines to load them into. Those units are considerably bigger than what these are, and I've got a length limitation inside the factory. There we go, there's 2 stacked. It's pretty cool. So that's why I opted for this type, for the destacker at the start and the restacker at the end. They only take 500mm in length on the line compared to 1.2 to 2.4 meters for the magazine-based ones. So I just didn't have that extra space. And I'm pretty happy with this. So let the last one go in. So it'll just keep stacking up. The tiny pico panels, I believe I can fit about 40 in there before I need to come and take them out. Maybe 45. So that's a pretty good chunk. That's more panels than I would make in one particular run of any particular board, unless I've got a special order on. So that's pretty cool. There's another panel in there somewhere that I fed in before. You might hear that kick in a bit later. So that's the oven. I have to say, I'm pretty impressed with it. It's got a pretty good build. There are a couple of quirks with it that I find, I guess, a bit frustrating, and I'll be honest about it. I mean, I've already mentioned it to Neodan a while ago. The width control, those green buttons, control some pretty hefty steppers that are set to these screw rods, and it's adjusted electronically. You push the button to go wider, and both of the steppers at the other ends, they go out. But there's no indication of what width you're on. There's no software over here control that shows you what the current width is, and no ability to set the width, even though there's steppers that are being controlled by the controller board. So all they would need would be some type of rotary encoder and a homing mechanism, and that would allow me to not only see the width, so when I'm adjusting it, like I know what width I need it to be. If it's a tiny pico panel, it needs to be 99mm wide or 100mm wide. There's plenty of leeway in this. So it'd be really great, instead of me having a one profile for everything, I've got enough positions here that I could put like my tiny Pico panel, my tiny Pico UFL, tiny S2 and tiny S3 panels are exactly the same width. So I could have a profile that's SAC 305 water wash for my tiny X boards, and when I click it to set that profile, it would automatically adjust the conveyor width based on what I want it to be, based on what's saved in here. Like, that seems like a really massive missed opportunity on an oven like this when it's all digitally controlled. If there was only a manual control for the width, sorry, it's my compressor kicking in. If there was only a manual control width, fair enough, that would be a really hard thing to add. But there's already digital control to adjust the width anyway. It seems like a $30 extra bit of hardware for a couple of encoders and just a little bit of software, and they could have had a much more user-friendly adjustment thing. Now, to be fair, none of the Chinese machines that you can buy, whether they're like a chain like this, whether they're mesh or whether they're mixed mode ones, you can get mixed, have that type of functionality that I'm talking about, but most of them don't have digital control either. They've only got a manual width control. So the digital's already here. It would have been nice near then if you would have added that functionality. That would have been a really nice quality of life thing for users. Other than that, really, I gotta say the oven's great. Like, from the very first reflow I did, which reflowed fine, I did a couple of tweaks after that, and I tweaked the wrong way on one panel, and there was a couple of parts that I had to hand fix. Tweaked it the other way, and I've been getting perfect reflow out of this oven, including my water-based paste, which I actually stopped using on the IN6 because it just wouldn't reflow it properly. The process window is very specific. This is allowing me to be very specific on the process window. So it's been reflowing great. So there you go. We got a board yet? Oh, here it comes. Good timing. There's only 4 I put in there. There we go. There are the 4 panels. All done. Very excited. Let's put them down here. So that is my line as it stands right now, going from the start. Well, of course, I've got my manual stencil printing station, which I still use occasionally. Actually, I use it quite a lot at the moment because not all of my stencils have fiducials on them to work on the automatic stencil printer. And sometimes it's just easier for me to do a manual stenciling if I'm only doing 2 or 3 panels than it is to turn the automatic stencil printer on, get it all in, calibrate it, get all the paste out. The amount of paste you need to stick on a stencil for the automatic stencil printer is like 10 or 15 times the amount of paste I can get away with on the manual stencil printer. So sometimes this is not worth running this unless I'm doing, 5 or 6 panels or more. But manual stencil area, I've got my D-stacker, which feeds panels into the conveyor, which goes into the automatic stencil printer, which I'll show you something really cool in a moment, which then goes into another conveyor for inspection just for now, until I'm 100% confident with the stencil printer. Then goes into the pick and place machine, then goes out here, and sometimes I'll inspect a board, maybe the first panel of the run, I'll inspect to make sure everything's fine, then I just let it go through, goes through the oven, watch the pole, and goes to the restacker. So apart from changing components in feeders when they run out during a run, and any potential other errors that appear, it's now a fully automated line from start to finish. I could put 20 panels in this end over here, get a whole bunch of paste on there, get everything ready to go, and hit the button, and it will start feeding panels through. It'll feed one into here to start going. It'll feed a second one into here to wait for this to go. And then as soon as that panel comes out, it'll feed through into the pick and place machine. If the pick and place machine is busy and there's a panel already pasted, it'll sit and wait on the conveyor before it feeds it through. There's also an extra one that'll wait over here in the start of the conveyor, so there could be 2 lined up ready to go while one is running, while they're feeding through the oven and restacking again. So the whole purpose of going fully automated for me is that it's still just me here. My options were don't go fully automated and employ someone to stand here babysitting the line, or chew up all my time doing that, or go fully automated so I can walk away. And apart from changing feeders, changing parts, or coming down for any particular beeping error that happens, I can go do something else. And those 20 panels from here should end up fully populated and reflowed down there. And then when it's done, or when I'm ready, I can walk up at any stage and grab however many panels there are on the end and start inspecting them. So this has been my dream ever since I started buying assembly equipment, and it's why I moved into this factory, to be able to have the space to fully automate. There are a couple of machines that could also be added. I could put optical inspection in line. I don't really have the room, as you can see. Dirty area at the end. I'm getting really close to the edge. I need to wall that off. So I don't really have room to put any more equipment on the line right now. But this is pretty cool. Now, one thing I wanted to quickly show you here in the stencil printer is the unit itself had a manifold here, which I assumed was for the vacuum add-on that fits in here, where you can use a vacuum bed to hold your PCB in place when it's stenciling. And I could never get any air to come through this thing, and I couldn't work out why. And I ended up opening up down here because I wanted to add my cleaning detergent into this barrel down here, and it's got a sensor just inside which can detect when you're out of liquid. And I needed to find where the end of that cable was, disconnect it so I could get this out, because I can't get it out otherwise. And while I was sticking my hand in there, I knocked a tube that was on the ground, and when I grabbed it and picked it up, it ended up being this tube here that had clearly fallen off the manifold. So that is the vacuum tube. So when I plugged that back in and screwed it back on, let's close the door, all of a sudden I started getting vacuum coming through here. So what I've done is I've 3D printed, because I don't have the accessory that comes here, I've 3D printed a bunch of stands with magnets on the bottom. As you can see, this is for a Feather S3 width. There's 15 boards on them, so 5 across. And I've got one at the start and one at the end. And so I've got some hoses going through there, some hoses through there. I still haven't printed anything to clamp them down. I will do that. I've still been experimenting with this. But the reason the vacuum bed is really important is that sometimes panels come from JLC PCB, because of the way they're shrink wrapped, they have a slight bow on them. So here's a panel here. I can't use this one. It's got it arrived with damage. A whole bunch of silk screen missing on there. It happens. But because of the way they shrink wrap them and stack them, you can see that this is sitting proud a bit. It's not sitting flush on the corner there. And so when the panel goes into the machine here and it lifts it and it clamps the edges, it's got a clamp here and a clamp on the other side that come together to hold the PCB still. If there is a slight curve on one of the edges, it clamps that curve, the edge up. And when the stencil comes down, it can't sit flush on the panel, which means you don't get a good gasket, a good seal. So when it does its pasting, you can get either some paste that goes underneath the stencil, or you just don't have the paste stick to the pads properly, and when the stencil comes back up, it pulls the paste back off. So the vacuum system actually pulls the panel down flat before it clamps, which means it alleviates that whole bowing that I sometimes get on my panels. So I'm really excited about that. It's not the most elegant solution, and I need to make a version for each width of the boards I put in, but that's okay. Those ones there work for all of my Feather style boards. So Feather S2 Neo, Feather S2, Feather S3, and then I've got a set that work for all my tiny boards, and then I can just do ad hoc ones. Or if it doesn't need it, if it's a thicker panel, like my Reflow Master Pro, I can just take them out and just use the normal supports that the machine came with. So I'm pretty excited about that. I just had to replace all of these fittings because the ones that were in there were pretty destroyed and old. They were missing O-rings, and they were missing the press fit section. So I replaced all of these, got myself some new pneumatic hose, and it's working great. So, that is my line. Finally, everything has come into place. So the next step for me, it's probably going to be sooner than later, is to take this out of my line and replace it with a real machine. Something that's a little bit more advanced than the Neodyne. Stay tuned on that. Okay, thanks for watching. If you liked the video, please give it a thumbs up. If you're new here, or if you haven't already, please subscribe to be notified when I have new videos coming out. Click the alarm bell, and I will catch you next time. See you later. Bye.